introduction to PoE as an effective and sustainable option for power management. Just a few words before I go any further. I just want to give you a brief insight to SILVERTEL for those of you that haven't come across SILVERTEL before. We were formed in 1997, so we've been in business for 26 years, and we were founded from two guys that left Mitel Semiconductor, which is now known as Microchip, after a number of different facelifts of the company. The photograph there shows Chris Green on the left, the retired CTO, and Steve Edwards next to him, the outgoing CEO. And I'll say the outgoing CEO because there have been significant changes in the last 6 months or so that means that Steve is going to take a step back from the business. But anyway, Steve set up the business with Chris 26 years ago with an experienced design team, specializing in power and analog electronics. We have good local university involvement, and we've managed to bring some graduates into the business and develop those into all-rounded engineers. So we've got a very strong sort of innovation ethic, as well as quite a lot of experience in power over Ethernet and the application of those kind of circuits. At the core of our beliefs, if you like, and our sort of approach to design, we want to make the products easy to use, cost effective, and for our customers to implement them easy and therefore be able to go to market very quickly. We have a world-class support team backing up that development team, and we respond within 24 hours. That's our sort of mantra, if you like. Most technical queries that come into that desk are answered within, say, half an hour at most. But we tend to sort of suggest that it's going to take 24 hours for some of the more challenging questions. And believe it or not, there are still quite a lot of challenging questions that people pose on the application and implementation of PoE. So we've got quite a strong knowledge and of the PoE standards and the applications. We've helped numerous customers over many years successfully gain approval of their products going into the field, and support those via the approvals agencies as well. So all in all, we're world leaders in PoE module development, and that has been the mainstay of our business over the 27 years. We have probably 80% of our product portfolio is dedicated to power over Ethernet. So like I said, we've got a long track record and a lot of understanding in that area. We're a financially secure company with strong sales growth. I think every year since the company started up, we've been in profit. So, you know, there's no worries about whether or not the company's going to survive a downturn or anything like that. As far as sales support is concerned, we have full global reach across all of the main regions of the globe, in the US, the Far East, and Europe, especially. And we complement that with our worldwide network of distributors, CODICO being one of them, and probably the largest one in Europe. And they do a very good job for us, I have to say. And I'm not saying that just because they're on the seminar today, but it's a fact. So we also have a network of representatives in the US.
Mike,
and
sorry
yes.
to step in again. I think you're showing the wrong screen. We have a delay in the slide. So what we see right now is a slide saying sales support and the world map. That's
yes,
it.
that's okay.
No text.
So I'm trying to step through. It sounds as though there is a bit of a delay. Hopefully that'll iron itself out for one reason or another.
It could be the preview. It could be the preview screen.
Okay. So
if you know what I mean.
Yeah. So I've got Are you seeing this full screen?
Yes, but just sales support and the map.
Okay, all right. Well, I'll do my best to try and rectify that as we go through. I don't know how else I can alter this now at the moment. So we're one of the largest, if not the largest, PoE module supplier in the world. We've manufactured over 40 million units, and that figure was based on production figures from 2 years ago. So we've definitely exceeded that by now. We produced around about 3.5 million modules last year. And yes, it was an unprecedented year, as most of you will be aware, due to the catch-up and the situation with the COVID pandemic. It was an exceptional year, and we're trying to get back to some kind of normality, whatever that is, at this stage. My screen is frozen now, so I'm having a bit of a mare today. I'm sorry about this. So as of August this year, as I mentioned earlier on, Steve is stepping back as managing director, as CEO rather. He sold the company to a company called Discovery PLC. They're a FTSE 250 trading company, and they have a very much hands-off attitude towards business management. So we form part of around about 20 other companies within the Discovery group, and it's a very positive move for us, and is one that is we consider to be business as usual in terms of whether how the company operates. So there shouldn't be any difference in the way that we run the business. If you knew Silvertel before that, before the takeover, compared to how it is now. So moving on, we'll get into the PoE side of things now, and I hope you can see the change in slide. So Power over Ethernet. What is Power over Ethernet? It is the ability to transfer power from one point to another within a system over one cable. In order to do that, we need some prerequisite sort of building blocks, if you like. The power source and equipment, or injector, at the input side, the upstream side, which is normally in the form of a PoE switch. The power device, the device that you want to power, normally the device that you're also sending data to, so that it becomes a fully sort of powered unit rather than a passive unit, or separately powered with mains, or maybe even through an AC power adapter to DC. Then we have the cabling that sits in between, predominantly Cat5e or Cat6a cable, which has a maximum reach of 100 meters. And I can see that my screen is frozen again. I'm sorry about this. So yeah, the PoE powers the PD through a data link cable. That data link cable, Cat5e, Cat6a cable, as I said, is something that contains 8 copper wires split into 4 pairs of cabling, 4 wire pairs. This slide, if only it would move on. There we go. So this slide also goes on to show how easy it is to convert from a non-PoE system to a PoE system as well. So we have here a PoE injector, which, if you incorporate it in a non-PoE system, it's known as a mid-span. If the system is designed from scratch to have PoE enabling, then it's termed as an end span, and that is the main difference between sort of mid and end span devices. So moving on. So what are the benefits of using PoE? Firstly and foremost, the deployment is very, very easy. The cost of deployment is cheap as well, which makes it a favorite with a lot of installers. You have complete flexibility in siting and location, and you don't need hardwire mains cable installation or qualified electricians to be able to power your systems. So that's a big saving as far as installation is concerned, and comes at a much lower cost as well. The voltages that we're dealing with within PoE are all classed as self voltages, so they're below 60 volts, and it is a proven technology as well. As you can see from this small illustration, a non-PoE switch would require a separate powered device using a mains adapter to a DC connection to be able to power in this instance, it's a camera of some sort. And instead, what you can do is just use a PoE switch with a single Cat5e or Cat6a cable connected to the camera to be able to provide you with exactly the same functionality, but without all the hassle of installing cabling and getting qualified electricians to sign off. The next slide. Where did PoE come from? Well, in order to understand that, we've got to go way back. Now, I'm not going to go right back to the late 1900s, but all suffice to say, the Ethernet network wouldn't be available without the old plain public switch telephone network that used to exist in the early 19th century, and has sort of developed in its very early days, legacy telecom systems sort of branched out from just carrying analog voice signals to analog interpretations of data using amplitude modulation or even frequency modulation to be able to provide data connections. The insatiable desire for people at large to require faster data transfer and greater capacity and also reliability drove people towards looking for another option. Enter Ethernet. And Ethernet at that time in the mid 80s, 90s started to expand in its use and deployment. Passive PoE systems using PoE switches, using Ethernet switches were very common. Less so with power over Ethernet at that time, but early in the 2000s, the noughties, as they say, power over Ethernet started to take its place and expand into everyday applications. So the question at the time, before PoE actually came to being, was whether or not an Ethernet cable could actually carry power and data at the same time, whether it could be done safely and cost effectively, and whether we could, as we expect today, and I think everybody from youngsters right up to grandparents expect to have internet access these days, and can we remain always connected? And I think the answer to that was a resounding yes. The IEEE, the Institute of Electrical and Electronic Engineers, formulated a new standard, which was IEEE 802.3, which is the standard for power over Ethernet. And it defines the requirements and the expectations, the properties of the systems which should be in place to deliver power over Ethernet. So as you can see, the standard Cat5 Cat6e cable is terminated at either end by an RJ45 male connector, and that has been the format since the year that Ethernet actually kicked off. So all we've done is added in the additional conductors to carry the power. So IEEE 802.3 AF allowed 15.4 watts of power to be transferred, and that standard was ratified in late 2003, early 2004. And it allowed, as I said, devices to be powered from the Ethernet via one cable. In 2009, that was increased to 30 watts with the AT standard. And in 2018, that was modified again in the BT standard to allow transfer of 99 watts over one cable. So there has been quite a major increase in the amount of power that you can actually transfer over 100 meters of cable. The standard defines a handshake negotiation process between the PSE and the PD and vice versa to deliver power in an extremely safe and reliable way. It also provides the opportunity for devices manufactured by different manufacturers to be completely compatible. That's the theory. There are still devices around today that are not compatible because they don't follow in its entirety the requirements laid out by the IEEE standard. But that aside, I would say 99% of devices these days operate totally compatibly with other devices. As far as the standards are concerned, the AF and AT editions only allow transfer over 2 of the 4 pairs. The later standard, the BT standard, allows transfer of power and data over all 4 pairs and reduces losses. So in that respect, along with a few other additions to the standard, the BT standard, the IEEE has become far more sort of aware and encompassing of energy saving features within the IEEE standard. And again, as I said, it's over 100 meters maximum, 328 feet, which provides more than adequate coverage for a lot of applications these days. So the implementation of PoE, as you can see, starts off with the PSE on the left. You have the PD on the right. And as far as SILVERTEL is concerned, we have modules that cover both functions. So we have a PSE module that you can buy off the shelf as a standard product. Likewise, we have PD modules that you can also buy and evaluation boards for your applications to find out whether or not they are suitable for what you want prior to you laying down any sort of CAD drawings or committing to any sort of prototype devices. Excuse me, it's just oil in my throat. So yeah, as far as implementation is concerned, typically looking at a 10 or 100 base T system, which is the AF or AT. This is the 15 to 30 watt sort of implementation. Power can either be delivered over the data pair set or over the spare pair set. And these are known as alternative mode A settings or alternative mode B settings. There is no way of from the PD end, there is no way of knowing which pair the power is going to be transferred on. So hence we put bridge rectifiers in to be able to terminate the line and also to polarize the line ready for presentation to the powered device, the module at the back end, converting into the application that you want to power. Alternatively, the BT standard, oops, sorry, excuse me, let me just take a step back. The BT standard, as I mentioned, allows transfer over all 4 pairs, and the implementation of that allows all 4 pairs to have power injected on the secondary side via the center taps, and to be split off from the PD end via the primary coils of the data transformers. So that is how the implementation works. And as I said, in between you've got data and power that's carried over the Cat5e, Cat6a cable via RJ45s. So that just gives you an idea as to what the architecture is in terms of the hardware implementation. So as I mentioned, it is a safe way of delivering power. And as I mentioned, there is a negotiation process that takes place between the PSE and the PD. And it starts off with an identification of the PD to the PSE. So plugging in your RJ45 into the PSE, the first thing the PSE looks for and sees is, well, we've got a termination on the end of this link. Is it a valid PD? So the PD should present round about 21 kiloohms in a purely resistive load to the PSE. And the PSE checks that by sending out two pulses at different amplitudes, and checks the DC current draw from the PD to ensure that you've got a straight line, a resistive load there. And provided it's within the required sort of limits, which would classify as a PD, then the PSE says, right, okay, you're a PD. So what power do you need? So this is the second stage. It's the classification stage, and the classification for the different types of, let's say, revisions, whether it's AF, AT, or BT. The classification process gets more complex as we go up through the classification standards. When AF came about, there were only 4 classification levels. When the 30-watt AT revision came to being, there was an additional classification, which is classification 4, power level 4. And consequently, going to BT more recently, we have an additional, I think it's 4 classification levels, and we'll come on to those in a short while. So as far as the classification levels are concerned, what the PSE does, it sends out a voltage pulse, and depending on the termination from the PD, the PSE will measure the corresponding current coming back from the PD. And again, provided it sees the corresponding current at a whatever level it's meant to be, it will see it as a class 0 to class, say, 3 device, for example. And what I mean by that will be evidently clear when we come on to the next slide. If the if the PSE doesn't recognize the PD, then the PSE doesn't deliver power and just switches off. If we get a situation where the PD is a lower power PD, so for example, if you've got a 15-watt PD connected to an AT PSE, which could deliver up to 30 watts, the PSE won't deliver 30 watts. It'll see the PD connected as being an AF PD and only deliver the maximum power that the PD has got classification for. So it is very intelligent in that respect, and only supplies the power that is actually necessary. In a similar way, if you've got a PD that is, for example, demanding 30 watts of power, and you've only got a 15-watt PSE, the PSE will only deliver that 15 watts. It can't physically deliver any more. So you would only expect to see 15 watts at the PD end. So as I said, it's a very safe method of power delivery. This table defines the power classification levels. And as I said, with class 0 to class 3, these are the AF power levels. We have pulses that are their amplitude of which is between 0 and 4 milliamps for class 0. 9 to 12 milliamps for class 1, 17 to 20 for class 2, 26 to 30 for class 3, etc., etc., etc. And with the AF, we only had one classification event. So it's one pulse that's sent out, and the PD has to terminate that correctly. So it needs to know within a specific time frame when the pulse is being sent from the PSE to be able to present the right load to for the PSE to be able to measure the corresponding current and therefore recognize it as being a certain class. As I mentioned, the 80 classification level is somewhat different. You have 2 or even 3 classification events, which means that the PSE will send out 2 pulses or even 3 pulses at anywhere between 36 and 44 milliamps, which would indicate to the corresponding PD and the PSE that the device is looking for 0 to 30 watts of power and demands that level of power. For class 5 to 8, these are the BT levels. So this is the BT standard where we can deliver 99 watts of power from the PSE termination from the PSE terminals into the RJ45 and down the Cat5e, Cat6a cable. And you would expect slightly less than the 99 watts that starts out at the far end because of I2R losses, resistive losses through the cabling. There will be a corresponding power reduction at the PD end. So you won't see the full 99 watts at the PD. It is somewhat less, but generally over 100 meters of cable, you can get up to 85 watts of power these days over the 4 pairs. And as you can see from that classification table, when you're up at anything above 75 watts, the classification events change to 5 classification pulses, which means that the PD at the terminating end, in terms of its classification determining circuitry is concerned, becomes a lot more complicated. But having said that, I mean, it is a very reliable and, as I said, a very safe way of delivering power to the line. So where are these devices actually used? And I think as far as PoE is concerned, right now there is a big explosion in the world of IoT and IIoT. The Internet of Things is a big area for us as a company, and there's a lot of overlaps in IoT. So the word smart is one of these sort of characteristic headings for the world of IoT. So smart factories, for example, smart traffic, which can be subdivided into smart city and smart vehicles, and smart infrastructure is a big thing. Smart buildings, smart transport, both in rail and maritime, and also in the home as well. As far as advertising, as far as inventory control is concerned, smart retail also has a very big part to play in the lives of shoppers. Smart agriculture, it's everywhere you look. Everybody is looking to try and incorporate some form of intelligence into what they're doing to be able to manage things far more effectively and far more cost effectively, and also energy efficient wise, far more efficiently in that respect. So as you can see there are lots and lots of applications that, as I said, there are a lot of crossovers between different application areas, different technology sectors. For example, security systems incorporate not only CCTV cameras, for example, which are powered from PoE, but also keyless entry systems, so card entry, biometric sensors that are built into entry systems as well, door locks. There's a whole plethora of different applications here that are not just used in security systems within buildings, but are also starting to be incorporated into the home as well, and in an awful lot of other different areas of everyday life. So there are a couple of variations on a theme. I'm not sure whether any of you will be familiar with single pair Ethernet, but single pair Ethernet falls under the heading of power over data lines, which has its own sort of standard within IEEE 802.3. It's CG, and as the term suggests, it is delivery of power and data only over two wires, one single pair. And for all that, it sounds as though it could be a very cost-effective way of being able to deliver power and data. It has an increased number of classification levels. We'll come on to see that in a slide a little bit later on. There's an additional 10 classification levels, 16 classification levels that allow single pair Ethernet to work. There are no magnetics involved. So as with traditional power over Ethernet and Ethernet systems, you'll see that transformers and magnetics play a big part in the application and the implementation of power over Ethernet. With single pair Ethernet, that's not the case. You don't have any magnetics to be concerned about. So there are reduced copper requirements. It's a simplified design. There's reduced weight. There's a lot of things that everybody would probably think, well, that sounds a really good way to go. We implemented a demonstration system for single pair Ethernet a short while back when we went to ISE last year. And in order to do that, we needed to buy some specific cables for terminating the line and to be able to carry the power and the data between the PSE modules that we have and the PD modules. And that cabling cost us, I think it was something like 25 euros for the cable, and it was only a meter long. So there are other constraints which prevent this from being adopted as a blanket sort of universally used technology, and I think it boils down to the fact that the economies of scale are not really there at the moment, but you know, that may change over the coming years. As you can see from the small graph illustration there, that 802.3 CG can operate up to 1 kilometer, but at very low data rates in comparison to Ethernet transfer. And it can actually increase that data rate, but you compromise on the distance that you're actually transferring data over. But we have had a working system here, and we occasionally are asked for applications and information relating to single pair Ethernet, but it's far less common. As I mentioned, the single pair Ethernet sort of power classification falls under the heading of power over data line, and as you can see there are 10 classification levels on the top. There are a further 6 which increase the power delivery in the table at the bottom. And as far as SILVERTEL's concerned, we can only really accommodate the latter 2 in the top table, so class 8 and class 9, and also the higher power classification levels in the bottom table. And the reason for that is because, as I said, traditionally our PoE modules support standard power over Ethernet. So one of the requirements of that is that you have to be able to deliver power. We're only able to deliver power for sorry, I've lost my train of thought. Yeah, as far as PoE is concerned, you're only allowed to deliver power at 40 volts, and that is the minimum requirement for PoE. So operating at voltage levels below 40 volts and below 36 volts in particular is going to be a problem for our standard products. So our products aren't particularly designed for single pair Ethernet, but you can use those products in single pair Ethernet applications if they are meant to deliver higher power in those particular circumstances. So looking at the next slide, the implementation is a very simple implementation. It comprises of filters comprising of inductors and capacitors. The inductors are there to block the AC and to allow the DC to pass. And similarly, the capacitors are there to block the DC and allow the AC to pass. But we have had systems running, as I said, with very specialized cables to be able to deliver power up to gigabit Ethernet type speeds, but only over short distances. So as far as the outlook for PoE for single pair Ethernet is concerned, as I said, everything that I've mentioned sounds as though it could be something that is attractive to, for example, the automotive industry, and to industrial automation, factory automation applications, because all of those things, the reduced copper, reduced weight, reduced cost, and simplified implementation would, on the face of it, present quite an attractive proposition. But as I mentioned, the economies of scale are really not there to be able to justify the development of PSEs and PDs at the moment. And that's certainly the case with Silvertel. We wouldn't entertain developing new single pair Ethernet modules specifically because the volume just doesn't seem to be there at the moment. As I mentioned earlier on, there is the data rates are achievable to compare with gigabit Ethernet, but the distances that you can actually drive over are way reduced. That may change over time as materials improve and technologies improve, but it's not something that we currently have an eye on at the moment, and there don't seem to be many people that are actually doing anything with it. The cabling connectors and PSEs are expensive. A lot of companies require return on investment, and that in itself is a barrier to entry. And I think if the automotive or factory automation sector decide that they're going to use single pair Ethernet, then there has got to be some compromise in the commercial considerations by the manufacturers of connectors, of cabling, of PSEs, for example, that would allow the technology to become far more competitive compared to standard Ethernet. And that in itself is a barrier to entry. The competition that exists with standard Ethernet and CAN bus applications within the automotive sector, it prevents the SP having a foothold and becoming more popular in those kind of application areas. So just so that I can get my opportunity to publicize our PoE modules, we've got a number of PD modules as well as PSE modules. These are very small devices. As I said, they're designed for ease of implementation and ease of use. These deliver the 9900, for example, is a variation on a theme. We launched this one probably about 6 to 7 years ago, and was available in a surface mount format using gull wing leads. But we've since moved on from that, and we're starting to populate them with gold block termination technologies so that you can surface mount these from tape and reel. So this is a device that provides the identification, the classification, the isolation requirements, which is 1.5 kV between input and output, which is a requirement of the IEEE standard, and is a fixed class 0 device. So it'll deliver up to 12 watts at 12 and 24 volts in the MTB option. Unfortunately, we haven't got a 24 volt version available in the LTB. But it provides a very cost-effective route to be able to deploy power over Ethernet. As far as voltage options are concerned, we have a number of different options: 3.3 volt, 5 volt, 12 and 24 volt in the MTB versions, and only 3.3, 5 and 12 volt in the LPB versions as well. As I said, very small form factor, probably the smallest in the market, smallest in the world, and we publicize that as such on our website, as you're probably well aware. The AG5700 is stepping up a power level, so we go to 30 watt power delivery, 30 watt peak. It'll deliver 24 watts power continuous at 12 and 24 volts. So you would need to buy separate versions if you wanted to power at 12 volts as compared to powering at 24 volts. We don't have one module that'll be able to deliver 12 and 24. It's a fixed class 4 device, so we'll signify to the PSE that it requires the 20 or the full 30 watts delivered to the from the PSE to the Cat5 cable. Again, available in surface mount and available in a tape and reel format as well. And this one, until just recently, we launched it late last year. And this has become the smallest PoE Plus module. Incidentally, some of the terminology that we use within PoE, IEEE 802.3 AF, commonly referred to as 15 watt power over Ethernet, or PoE, is another acronym. Similarly, the AF power levels, which is 30 watt, is referred to as PoE Plus. And in the BT standard, a lot of people refer to it as sort of 99 watt or 100 watt, as near as damn it, or PoE plus plus. Okay, so it's just a terminology thing. So looking further at other PoE modules, we've got a high efficiency 30 watt device, and in keeping with designers' sort of drive to do more with less power, or the same amount of power, and get more out of their products, we are stepping up the efficiency from traditionally 87 to 88% in our AG5300, which was the forerunner of this device, to 93 watts. Sorry, to 93% efficiency. And it doesn't sound like a huge improvement, but what we're doing is cutting the losses in half. So if you imagine that we've got 88% efficiency, we've actually got 12% power loss somewhere along the system, predominantly within the cabling and within the conversion losses on the module. But the 5400 and higher efficiency modules that we're bringing to market now, we've managed to cut those losses in half, such that we are now delivering around about 92, 93% and above. So, as I said, they become not only a very space efficient, but also a very energy efficient option to be able to use. This particular device is only supplied in a single inline format. Some customers like that because it takes up very little footprint and very little space compared to a surface mount device, despite the fact that the surface mount devices are quite often only the width of an RJ45 socket, for example. And again, this device is available in 5, 12 and 24 volt variants. And as I said, runs far more efficiently at 93% and runs touch cool. So they can be used in elevated temperature applications where the temperature is quite high, and allows you to be able to get the full 25.5 watts at the PD end, considering we're sending out sort of 39 watts at the PSE end. The 5810 again is another step up in power and is a 60 watt device. It's a PD module, again delivering 12 or 24 volts at 60 watts, and again is fully BT compliant. It's a class 7 device, and again available as a dual inline, not surface mount, but a dual inline format using pin headers. But this device is due to undergo a bit of a facelift in the very near future, and will be producing a surface mount gold block termination version of this device. Incidentally, that forms part of one of the next slides. And again, as I said, this one is available as a 12 or 24 volt version. The PSE modules that we have on the market at the moment, the 6120 supports AF/AT and BT 2-pair power in, not 4-pair power in. It was originally developed for the Ultra PoE. I wouldn't say a standard, but it was a proprietary system that was developed by the likes of Cisco, who became impatient with the time that it was taking to go from IEEE 802.380 to BT, and decided to come out with their own version of the standard, which is commonly referred to as PoE Ultra or UPoE. So this particular device will deliver up to 74 watts over 2 pairs, which is what the UPoE sort of architecture and system allowed. But in that respect, it's not IEEE compliant at 60 watts. It's only compliant up to 30 watts against the BT standard. It has programmable output power, which allows you to be able to deliver the different powers required to the line. It's available as a single inline format, and you need no external components in order to implement it into your PSE design, or even into PCs or similar type of applications where you want to incorporate power over Ethernet connectivity. Again, the 6800, the AG6800 is another PSE module that's available off the shelf. It's BT compliant and delivers up to 99 watts on all 4 pairs. So this is fully BT compliant and complies with the 4-pair power in standard developed by the IEEE. It has a dual signature recognition function, which allows 2 PDs to be powered from 1 PSE port. And provided you don't exceed the power requirements of the PSE, then you could conceivably deliver up to 45 watts of power from 1 PSE across 2 PDs, which is a bit of a departure from the previous versions of the standard, which concentrated on delivering only 1 PSE for 1 PD. And again, that's a feature that we'll come on to talk about a little bit later on. It's only available as a dual inline format, but again, we're going through a facelift process at the moment, and we will be releasing an upgraded version of this, which is a much smaller version, and something that we're very proud of. We're continually pushing the bounds of innovation with the modules that we produce to come up with a surface mount equivalent. I know this for a fact because I've seen the initial prototypes, but it won't be available until in the second quarter of next year. But again, provides a very powerful way of being able to deliver PoE power to PDs. So the 59600 PD module is one that's in development at the moment. We're just finishing off verification. It's a 50-watt device, so it's a fully 802.3 BT compliant class 6 device, powering overall 4 pairs, and it's a high efficiency version, and it's delivering in excess of 93% at 12 volts, and we expect something similar for the 24-volt version as well. It's available as a surface mount option. It's available on gold blocks only, and again, represents a major reduction in size compared to, say, something like the AG 5800 or 5810, which are our standard BT modules that we have on the market at the moment. And again, this one, we like to lay claim to the fact that it's the smallest BT compliant PD module on the market, and hopefully some of you will get to sample that very soon, and will be available through CODICO for that. Release is planned in early in 2024, so early next year. As far as PSE modules are concerned, we have the 6130 in development at the moment. Again, format very similar to the newer devices that we're developing on gold block terminals. And again, it'll support AF, AT, and limited power for BT as well. But it'll also support the 60-watt proprietary systems that some customers like to use these products in. It has programmable output, but it also has an output disable, so you can actually switch the output off and switch the DC to DC conversion off from the PSE module. The surface, it's available as a surface mount device, and the width of this device is as I said, the same width as an RJ45 socket, so lends itself to being tape and reeled in a similar way as the 9912, sorry, the 9900 module and the 5700 module. So those will be available very, very soon. We're planning release on that towards the end of this year and early into next year. So again, watch out, watch CODICO's website for sample availability and order that in advance if you can. So as far as trends in our market are concerned, more and more these days we're seeing a focus on energy consumption and energy efficiency. This is the theme of today's environment and environmentally friendly sort of approach to technology these days. Energy conservation has become a much bigger topic for designers over the years, and they're expected to do at least the same as or more with less energy if possible. An impossible task, I know, but hopefully with some of the modules that we're developing, it'll at least get you to do at least the same with higher efficiency. It's recognized that the PoE technology is an efficient method of being able to deliver power these days, just by virtue of the fact that you have complete flexibility over the amount of power that's delivered to the end termination, to the application. And also in the fact that you have different classification levels that allow you to be able to move within those bands as well. So it's not just 15 watts and that's it. You've got sub bands within that and sub classification levels to be able to program and deliver power at lower levels if required. We know from our own experiences of developing more PoE circuits that trying to squeeze as much efficiency out of devices becomes more and more difficult as you start to scrabble around for smaller improvements in efficiency, and that all comes at a cost. And obviously there's a return on investment figure that is we have to balance there. But you know, what we're trying to do is strike a happy compromise between trying to optimize the level of efficiency with the time that it takes to actually get there and physically achieving the higher sort of efficiency levels that we can. It would take forever and a day to get down to get up to sort of the high 90 levels because of component technology. But again, who knows whether things may change in that respect. As far as pack-in density is concerned, because IoT is becoming far more sort of integrated into everyday life, there are sensors deployed in every building, every application on public transport, in buildings, in the streets, for example, for lighting, for air control, air monitoring, and stuff like that. So the drive is to make the devices as small as possible, to make them less obtrusive, to make the internal circuitry less accessible. But in doing so, it means that we're actually increasing the power density of some of these modules. So in some respects, we're creating another issue with regards to whatever power dissipation is incurred through the deployment of these modules. It becomes more difficult to actually get rid of that heat and that power, and more often than not, lost power does manifest itself in heat. So thermal management becomes a far more critical consideration to make at the design stage rather than as an afterthought. And I know in talking to a lot of customers that quite often they will get caught out by the fact that these are power devices. They will consume power, they will dissipate heat, and you have to make allowances for that in some smart ways, whether it's through forced air cooling with fans. And I understand the reluctance to want to incorporate fans into enclosures purely because of the space and the cost associated with it. But there are other ways of being able to dissipate heat in the form of passive heat sinking and thermal transfer paste and thermal transfer compounds that allow you to bond those power devices to surfaces that would be able to dissipate the heat far more effectively. Excuse me. In terms of customers and what they're looking to do with the sort of architectures that are being deployed for power over Ethernet and for Ethernet in general, they're looking to, I guess, optimize the main sort of key elements that we mentioned earlier at the start of this presentation in the PSEs, the PDs, and in fact the cabling that goes between the two. So they're looking to combine PSE functionality with two ports being driven by one PSE, which you can do from the BT standard, as I've already mentioned. But also they're looking to power separate PDs with separate PSEs connected over a single common CAT cable. So they're sharing the cable, which is a very unusual let's say instance that we've come across just recently, but nonetheless, they've got good reasons for doing that. And obviously, if you can cut down on the amount of copper that you're laying down, then it has other beneficial implications as well. So all of this is in support of energy efficiency and driving the environmentally friendly sort of message within the industry. So it's doing the same with more or less. As far as some of those applications are concerned, just to show you what we're talking about, we've got two PSEs that are actually driving into two Cat5 cables. Data is transferred over two cables, and those two cables combine into one PD module. So the one PD is shared between those two PSE ports. That is an unusual situation, but is one that a customer has assured us that is more than sufficient to work and is very deployable, provided you don't get both PSE ports demanding power of the PD module at the same time. Obviously, you get one port that would actually manage to seize the PD, and the other would just not connect. So you have to be in control in some respects of the PSE that's powering the PD module at the end of the day. Similarly, sorry, the modules in those instances would be either our existing 6120 at the PSE side or the 6130, the new one that's coming around. And for example, with PoE Plus, where we've got 30 watts of power required, the 5700 would be embedded in the peripheral device that is not only accepting the data and transferring data back to the PSE, but also accepting the power as well. Just looking at another example where we've got a shared PSE, and this is allowed under the BT standard. As I mentioned, the BT standard PSE has dual signature recognition, which means that you can recognize the signatures on two sets of four pairs. Sorry, on two sets of two pairs at different times. So you've got the ability to be able to power two PD modules over a single PSE and a single data link as well. And finally, oh, sorry, the modules in this instance would be the 6800, the BT PSE module, as well as the standard AF and AT PD modules at the other end, which is our 9900 and our 5700 PD modules. Finally, the last example is sharing a data link, which is something that we'd not come across before. And what we have here is two PSEs that are funneling through one conduit, one cable, and branching out again at the other end into two PD modules. Again, this is doable. This is something that customers have tried to implement and have been fairly successful in doing so. But you have to have control over the wiring of the, let's say, the RJ45s, and you have to have control over the PSE and the PDNs of the network to be able to make sure that the right PSE is connected to the right PD pairs, essentially. Any any changeover, any mixing up of the pairs is just not going to be something that would work and would end up in tears for sure. So in those instances, again, the modules that we would choose to use could be, for example, our 6120 or 6130 at the PSE side. And at the PD end, at the peripheral device end, we would have the 9900 or 5700 similarly from our standard product range. So to conclude, PoE is very much an established technology, but is here to stay. It has been very well deployed over the years. And as far as IoT is concerned, I think there were something like, where we are today, we've got something like 15 billion connected devices to the internet. And a lot of those devices are connected via an Ethernet backbone. And by 2027, this is expected to nearly double to 30 billion devices. So there's a long way to go on this. So PoE is here to stay. It continues to grow in popularity thanks to IoT and other technologies. It's both reliable and flexible and easy to deploy, and as a result of that, becomes very cost effective in the way that it's rolled out. The architecture is so wide, so widespread. It's likely to be continued to be deployed as and adopted as the backbone for LAN applications in the final stretch within a data link. The fact that it's based on intelligent power management sits very nicely with energy efficiency and the conservation of energy, and the drive for companies and clients and customers, the public at large, demanding better efficiency in power management. So, as I said, still one of those technologies that hits all the right spots. And designers are becoming far more resourceful and creative in pushing the technology to accommodate different applications, while still remaining within the standards. But there are a number of applications, as we've already covered, that are certainly eye-openers for us, and certainly some that we didn't expect to see come into fruition. But you know, to the letter of the law, these are still compliant systems. And where they're not compliant and they're deployed into proprietary systems, then provided you have control over both ends of the data link, then they can be deployed very successfully. So SILVERTEL has got solutions for both the PSE and the PDNs, which help to make your life, the designer's life, the system integrator's life, a lot easier. As I said right at the outset of this presentation, our sort of mantra is that we make things easy to deploy, easy to implement, and therefore make it far more quicker for you as representatives of companies to get your products to market and to be able to start making money from the products that you launch. So As far as our products are concerned, keep an eye on our website. Talk to CODICO as our authorized representatives in Europe for any up and coming releases. And for any information, please don't hesitate to get in touch with us.